Good afternoon, sir.
Sarna ma'am,
Welcome,
good afternoon.
Naveen. Welcome, Naveen. Yeah.
உங்க முகத்தை பார்க்க முடியல.
நீங்க அது வந்து நான் ஃப்ரைடே காம்பஸ் சார்.
ஓ.
அது வரைக்கும் திரை மறைவுல தானே இருப்பேன்.
வெரி குட், வெரி குட்.
ஓகே சார், பிரின்சிபல் மேமுக்கு எங்க விஷஸ் சொல்லுங்க.
ஷூர் ஷூர், சொல்லியாச்சு.
அருணாக்கு சொல்லுங்க.
அருணா பெங்களூர்ல இருக்கு.
அப்படியா? சரி சரி சரி, ஓகே. ஆமா, அங்கதான் இருக்கு. பசங்க எல்லாம் நல்லா இருக்காங்களா சார்? நல்லா
இருக்காங்க.
ஓகே. ஒருத்தர் பெரியவன் இங்க தானே இருக்கான்,
ரெண்டு பேருமே வீட்ல தான் இருக்கறான்.
அப்படியா? ஒர்க் ஃப்ரம் ஹோமா?
ஆமா.
வாவ், சூப்பர்.
Hello, ma'am. Good afternoon.
Yeah, welcome, Naveen. Welcome, Naveen. Welcome.
Thanks, ma'am.
Okay.
Good afternoon, Naveen.
Good afternoon, ma'am. Happy Women's Day to all of my beloved professors.
Thank you so much. Thank you.
We are happy to have with us today.
Thanks a lot, ma'am. My pleasure.
Our beloved student.
Pleasure, ma'am. Hello, everyone. Ma'am, are we ready?
Yeah, we'll start with the formal welcome address.
Okay, ma'am.
Can I start, ma'am? Yes, ma'am, start.
ஒருமைக்கண் தான் கற்ற கல்வி ஒருவருக்கு எழுமையும் ஏமா புடைத்து. The learning which a man has acquired on birth will yield him pleasure for all 7 birds. A warm good afternoon to one and all present. I, on behalf of the Department of Computer Science, University of Madras, MHRD RUSA 2.0 Biomaterials Team 2. Welcome you all to the International Congress on Industry Perspective of Data Analytics Day 2. Welcome to those who believe in the power of teams and journey of knowledge sharing. A hearty Women's Day wishes to each and every Wonder Woman here. Not only today, you are very special every day. Be strong, be bold, be independent, and pursue your dreams amongst the obstacles. Today's topic is about data analytics and machine intelligence. I request Dr. B. Lavanya ma'am, Principal Investigator, Biomaterials Team 2, to say a few words about today's resource person, Mr. Naveen Kumar, Senior Software Engineer, Media.net, Hyderabad. Over to you, ma'am.
Welcome, Mr. Naveen. And Mr. Naveen Kumar is a proud alumni of Department of Computer Science, University of Madras, our own department. He has an expertise in business analytics, machine learning, deep learning, big data, Python, and Java. I'm sure he is going to enrich our knowledge on data analytics and mission intelligence. Welcome, Mr. Naveen Kumar, and the floor is yours now.
So the screen is being shared. So I need to share the screen. Yeah.
Yeah, you can.
Yeah. Thanks, ma'am. Sorry, actually my internet is not working, so I'm sending my details in the group. In case anybody is having any questions, I will be happy to take it offline as well. I will share my details in the group. So I was starting my presentation now. So I'm Naveen Kumar, and proud alumni of being a student of University of Madras, having 13 years of IT experience and almost 8 years of analytic experience. And yeah, working in Media.net as of now. The main role is like I build models, analytics models, deploy them on production. And today's agenda is about machine learning, data analytics and machine intelligence. So we'll talk about data, what is data, and how does it creates room for analytics and machine intelligence. And then we will see machine application and the latest trends that is happening in machine intelligence and how we can contribute. And in between, I'll be happy if anybody is having any questions, so we can clarify in between or after the presentation. So, let's talk about data. Like, what is data basically? So basically, data is any information, quantities, number, facts, like whatever you observe around you, everything is a data. For example, like height, width of the person, for example, what is the height of the plant, size of the petal leaves, each and everything is a data. Timing of the train, we all are aware. So this is the most important thing. And particularly until we have data, we cannot have anything to build on the data. So the most important thing, what is required now is data. That's what called is data is everything. And like how well you use your data can determine the degree of your success. This is why, because consider data is like raw material, and what you are going to build on data will be your building. For analogy, you can take, like, we have some cement and a brick and a few other things like water and all of the materials which are required to build a building, and we can build a material like our parliament, Burj Khalifa, or even we can make a very normal building. So that all depends on how we are going to think about the data. The material, the core material is data. If we are planning well on our data, then data can be the true thing for our success. And what like a bigger person like Peter Norvig has told, that we don't have better algorithms, but we just have more data. We see few more things like what the data is. Without big data, you're blind and deaf in the middle of a freeway. So because like there is no data, we cannot, our algorithms won't work. We can't have anything. So the most important thing we have today is data. And we are here to get knowledge that how we can utilize them better. And for data analytics, right? Data analytics is two-word phrase. So it's made of data and the analytics. So we have already seen what the data is, and coming to analytics. So basically, analytics is the detailed study of examining something to understand more about it. For example, right, like each and every sentence, word, we have to understand, because like one single comma in a given sentence changes the whole meaning of the thing. So that's what the data is. For example, like when we're writing a very small sentences in English, and if the comma or the semicolon is not properly written, it completely changes the meaning of the sentence. So that's what the analytics is. Analytics defines the data basically. So what the data is trying to say. So let's see examples. So in decisions, right, like this decision making is not very easy when you have thousands of millions of customers. For example, Amazon or Citibank, and how they are using their data is like, we can see the example. For example, Citibank manager decides if a customer is credit worthy, and this decide based on the data. Amazon decides who is getting pregnant, and hence offer on the baby care products. So they are well aware in advance by our searches, by using our IP address, that how can Amazon offer products to a lady who is getting pregnant. Ford decides who to give promotional offers. So like Ford doesn't give promotional offers to all of its customers, they give only to the few, and they decide it's using data analytics. So data analytics allows us to have clear focus on whom to focus. For example, like in case like advertisement agency, for example, when I do this display ads on internet, for example, say a product called refrigerator, then when I am showing the ads on refrigerator, even in an area like say Kodambakam in Chennai, like we have thousands of customers, but thousands of customers are not going to take that refrigerator. So how can we focus on those customers who are going to get this refrigerator is important. If we are unable to pick them, we are losing the business. If we are targeting whole the customers, then we are losing more money in advertisement than the profit. So how to focus is one of the most challenging tasks, and data analytics does provide it. At the same time, it cut cost, attract customers, solve problems, and innovate also. So innovate in the sense that when we know a customer's desire is growing in a particular region. For example, if my company say, if I'm owner of Amazon, say Jeff Bezos, and I know that I am not selling cars as of now, but I know that few of my customers are interested in buying the car. So there lies the opportunity for Amazon to sell the cars also, apart from selling books and other stuffs. So data analytics allows us to innovate. And how to do data analytics is a 5-step process. First step is like we collect the data, we measure the data. Once the data is measured, we analyze it, we improve it, and then we control it. Controlling means controlling the system, controlling the future based on the past data. And there are roughly 4 main types of data analytics. It can be many more, but roughly it's 4: descriptive, diagnostic, predictive, and prospective data analysis. So we will see one by one, what does it mean? So descriptive means like we try to get an idea about the data, like we summarize it, like roughly what is the average score for particular subject. So it gives an idea that if the paper was tough, or paper was very easy. So if the average student performs better, it means the paper was easy. If the score for the average student is very, very low, it means it determines the paper was less. So this is called descriptive statistics. And the tools we have is like measure of central tendency, measure of dispersion, measure of position, and measure of frequency. We'll see them here. So basically all of these things, the first part is coming under descriptive statistics. And here we try to get these things like mean, mode, median, and for variability, we get range, variance, and dispersions. Now comes to diagnostic analysis. So diagnostic analysis uses the data to answer the question, why did this happen? For example, like when we see, for example, every day, suppose 1,000 of customers are visiting a store, and suddenly if we see like 2,500 customers have visited the store. So when we see in the data, we will find that the average customer is more during that particular duration, and we diagnose why it happens. So it can happen due to many reasons. So nearby shops might have been closed. One of the reasons is this shop itself might be running some offer. So diagnosing that why the data has particular shape or particular average, particular mean, mode, or variance is called diagnostic analysis. And like we have tools to diagnose like histogram, box plots, etc., scatter plots, and all that. These tools helps in finding the outliers, finding the average, mean, mode, medians, and how they're scattered during the duration which we are doing the data analysis. And third thing is predictive analysis. So predictive analysis basically also refers as inferential statistics. So once we know that details about the data, like what shape, what size, what average, what mean, what mode, what median data is having, we can take advantage of that data, and we can target particular customer using our predictive analysis or inferential statistics. For example, when we know that particular customer can buy a product in particular range, say 100,000. So we have to target only those people who can pay this much money. We cannot target customer if a customer has been not paying that much or not in capacity to spend that much. So that's how predictive modeling helps in targeting good customers, and while it eliminates not targeting those bad customers as well. So it helps in like finding consumer behaviors, pattern, visualization, decision making, and a statistical model. And the same can be communicated using the model to get the better result. And the tools to do the predictive analysis is forecasting methods, classification method, decision tree, machine learning, text analysis, and regression. And now comes the last one called perspective analysis. So perspective analysis is like when we are in the last phase of data analysis, and we know that mean, mode, and average, all those descriptive statistical tool, plus we have inference also. Then if we apply that to our data, for example, target customers, what would happen? Because when we are applying those things, right, like we are not sure that if those things works, because that is only the prediction. So before apply predictions, we give a thing, it's called prospective analysis, like how the customer would benefit from this offer. So for example, many companies, if you see online, are running offer, but you can see that you might not be getting benefited with those things. So there come the prospective analysis. So if we are giving some discount, the customer should get benefit and try to shop more. So these are the things prospective analysis would try to find. And here are the tools which everybody is using nowadays for data analytics. MS Excel, top thing, SQL, R, SAS, Tableau, and some of the advanced tools are like SPSS, MATLAB, Python, Hadoop, Spark, Hive, and not limited to this, but to the latest tools also like MXNet, CNTK, PyTorch, and TensorFlow as well from the Google. And then now we have some of the case study, if you like to have. These are the case study from a company called Tridence. And here are the things. Automation of the freight auditing led to the saving in procurement cost. So cost decreased by using this data analytics. A spare parts rationalization helped reduce inventory cost. And so many examples, we can see that how these things, data analytics are saving more time, helping to target more customers, it gives better pricing and all that. So there are few of the case studies which I can give you in a link. Now coming to the second topic called machine intelligence. So machine intelligence is roughly a very new term. So it's highly confused with the term called artificial intelligence. So we will focus mostly on what AI has to do. So machine intelligence is another name for artificial intelligence that is demonstrated by robots. So it means that like some intelligence plus the data analytics. So given it will analyze and take appropriate action as per that. It is the product of machine learning, deep learning, NLP as well. At its core, machine learning attempts to mimic human behavior and so has to embody several cognitive functions along with non-cognitive component also. So for example, in a robot, right, like cognitive function is their brain, but non-cognitive functions is their body, which can be mechanical in nature. Other definition, intelligent machines and intelligent software rely on algorithms that can reason about the observed data to make predictions or decisions that are useful. Such systems rely on machine learning and artificial intelligence, combining computation, data models, and algorithm. And this is the definition as per Microsoft. And so coming to the topic, apart from definitions, we can see like what AI is. So AI is AI is the superset basically of the machine learning, artificial neural network, and deep learning. Not only limited to that, but it also has those portions related to particular subject like philosophy, mathematics, logics, physics, and all that. But those parts are applicable only for those parts of domain. So we can say that artificial intelligence is any technique that enables machine to solve tasks the way like humans do. And machine learning is a subset of artificial intelligence. So basically machine learning deals with algorithms that allows computer to learn from example without being explicitly programmed. So the core function here is machine learning. In machine learning, we will have the data, but we will not have those functions by which we write applications. And given the data, we expect machine learning to solve particular problem or to predict. And then comes artificial neural network. It's called brain-inspired machine learning model. We will see a bit later in the presentation what it is. Deep learning. So deep learning is also based on artificial neural networks and subset of ML which uses the deep artificial neural network as the model and automatically builds a hierarchy of the data. And in general, the current age is of deep learning, and the reason is because current algorithms, what we have, and we call it like classical machine learning algorithm, takes a lot of time to train, and they are good, but in general, they deep learning performs better than the classical machine learning algorithms, and the reason is data for that. Because deep learning methods can consume a lot of data, and they are built in a way to do that. So we can say AI is the artificial intelligence, is the intelligence of machine and the branch of computer science that aims to create it. AI textbook define the field as the study and the design of intelligent agents, where an intelligent agent is a system that perceives its environment and take action that maximizes the chances of success. So basically, in artificial intelligence, machines learn from the environment. So this is what the AI is basically, and they are free to take decisions, and in they mimic basically human behavior. So we can see these are one of the applications of AI. We can see that a robot is acting like a vacuum cleaner where human intervention is not required. And in a car assembly unit, robots are assembling the cars basically. And we have applications of AI in defense also, which we can see in third quadrant, like how robots can act like a soldier, or even if they are produced in mass, they can act as an army for any given nation. And in the last, we can see that robots can do the operation, and it's already in practice. And robots are helping doctors in doing operations also. And here few things we will see what AI has to do in a video here.
This is artificial intelligence. Speed with precision. Insight with purpose. Humans with machines. With. And on our hyper-connected planet, with is how you change the world. Say you need to sequence the genome of a virus in days instead of months to save lives. That's with. Or maybe you want to reduce your company's carbon footprint by using AI to automate supply chain decisions. Also with. Want to find fraud hidden in billions of banking transactions? Personalize your brand at every touch point. Or even use object recognition to prevent crashes autonomously. With, and more with. At Deloitte, we see that artificial intelligence isn't something to fear or marvel at. It's something to work with, to trust, which is why we help to make it ethical and accountable to your people, customers, and goals. Built on proven platforms to turn the unknown into the predictable. And tap a tech with business ecosystem that helps you reimagine at scale. You see, this is the age of you, and you, with every possible insight, with world-beating advantage, with extraordinary impact. This is the age of humans with machines. Harness its power with Deloitte.
I hope you might have liked the video, as it gives the wide array of things which are working with AI, humans with robots to make things much better for everyone. So we will look at the subset of AI called machine learning. So machine learning is one of the field of AI. It has many things to do. Basically, main thing which comes under deep learning is machine learning is classical machine learning, deep learning, and predictive analysis. And machine learning is also capable of doing natural language processing, translation, classification, information extraction, speech to text, and etc. So underneath, it is all machine learning. So how does it do it? Basically, machine learning takes the data, it calculates each and everything about the data. And when we apply to any given algorithm like linear regression or given classification regression or clustering methods, it creates the ability to predict the future of given data, and the output of the machine learning is called a model, which we apply in real time to forecast in advance. And here are the classifications that how the machine learning classification looks. Machine learning is basically a combination of three kinds of learning called supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, we are having data and we are also having the levels. In unsupervised learning, we are having the data, but we don't have the levels. For example, if we say, just to clear what the level means, for example, NINE is 9 and TEN is 10. Numerical. So we can say that 9 and 10 in numerical are the levels, and other part is called their data. And whereas in unsupervised learning, we don't have the levels. So we just have the data. We don't know which action was taken by which data. So it's unsupervised learning. And the third one is called reinforcement learning. In reinforcement learning, we neither have data nor have levels. So we don't have data, and how it learns it's being given an environment where it tried to maximize the profit. So there comes the reinforcement learning and how it behaves, like how the child learns the cycle. So basically, child has been given a bicycle and then it tried to ride it, and if it falls, the child doesn't mimic those actions which made it fall. So that's how the reinforcement learning also learns. And at its core, reinforcement learning tries to maximize profit in a given environment. And in supervised learning, we are having two kinds of algorithms called classification and regression. So in classification, we try to classify things in multiple groups, whereas in regression, we try to predict one value like weather forecast, temperature for tomorrow, or a stock price. In classification, we try to predict, like, if a given text is a spam mail, is a spam or not. In unsupervised learning, we are having clustering algorithms, and in reinforcement, we are having QRTD learning. And here are the list of the algorithms which can use for regression classification of any one of them based on the use case we have. So here we can see a basic linear regression example that it's tried to, how does it try to fit the straight line given the data. So we can see from the data, right, like it's almost following particular trend in particular direction. So if this red line, which is being straight, so that fits the data very clearly, we can say that, and it follows the a straight line equation, something like y equal to mx plus c. So this is the most basic example we have. And we can have data where it doesn't fit in a linear way. It can be curve also. So we can have a non-linear regression also. We can see it. How does it fit? It's called this non-linear regression. And more algorithms, like we can have the decision tree also. It helps that how which conclusion to arrive at. For example, we can predict that will it rain tomorrow? Will Obama win? Will Trump win? Something like that. So we can do it using an algorithm called decision tree. Decision tree is also having many algorithms like bagging algorithm and boosting algorithm. For example, random forest, XGBoost, gradient boosting algorithm, and all. And here is one of the example of clustering, that how does clustering algorithms try to form the cluster. So clustering algorithm try to starts with a normal random cluster example, and then it try to find different clusters which suits the data, and then it forms multiple cluster based on the requirement. And we are having k-means hierarchical clustering algorithm for clustering. And now we are going to see one of the most important algorithm called neural network. So what we are seeing here is a deep neural network, because and then how the deep neural network behaves is like it try to mimic neurons in the brain. So similarly, each neuron act like the brain of the given situation, and then it learns by calculating what the output is. Here, there is a simple example of the feed-forward network. So in this slide, we have seen that how deep neural network can be, and in this we are seeing just the basic form of a neural network. So we can have n number of input that will be passed, and all of these inputs will be multiplied through its different weights, initially a random weight, and then it will be summed up using some of the activation functions. It can be sigmoid ReLU, and then it predicts the output. So this is how it functions basically. Here, all of the random weights are being calculated, and the net output is calculated, passed through a activation function. Activation functions are required to make the output non-linear. If we don't have activation functions, a neural network will mimic just like in linear regression thing. And so to know why we are talking about deep learning is, it's most of the data what we have won't fit, and we don't have algorithms, normal classical machine learning algorithms where this data will fit. And even if fits, the computation time will be so high that it will not be able to calculate. So deep learning has the advantage of working on GPU, graphical processing units, where it computes everything, the gradients so fast that we can afford it. So deep learning is the subset of machine learning where artificial neural network algorithms inspired by human brain learn from the large amount of data. Similarly, how we learn from the experience, the deep learning algorithms perform a task repeatedly, each time tweaking it a little to improve the outcome. We refer to deep learning because the neural networks have various layers. So various layers means if it has a lot of layers, we call it deep. We can see how it looks, and the first neural network in 1980s was similar what we can see in the left, and how does it improve over period of time, and we have the state now. And we can reason that like why we are talking about deep learning is, so deep learning performs with the data, which most of the algorithm doesn't do. So the deep learning, we can see the performance improves. So performance is there on the y-axis and the amount of data on the x-axis. So as the amount of data grows, most of the learning algorithms saturates its performance, but the deep learning continue to do well. So that's why deep learning is most important thing we have. And why one of the benefits of the deep learning is that we can have automated feature engineering as well. So in classical machine learning, we need to take a lot of things into account, like correlation, how it's multicollinearity and all that. But deep learning takes automatic advantage of all of those things, and it gives the correct result. For example, like we can see that if a given tweet is there, we pass through neural network, it can tell you that if the tweet is offensive or non-offensive, polite. So it can do those classification, and it can do much better than classical machine learning algorithms. For example, sentiment analysis. So this how the new this is one of the example of classification using the neural network. So we have been given one input data. For example, here in this case, the data given is of dog, and how does it performs the network, learn through various neurons. As the neurons are passing, its weights are getting improved, and it learns what a given image is, a dog or a cat. And the algorithm behind the neural network is back propagation. So what does it do? We take an input X and Y, or X1, Y1, and then what does it do? It applies a random weight and generates the output. And then the output is being compared, generated output is compared with the actual output. And whatever the missing things are there, they are being back propagated using algorithm called back propagation. In mathematics, it is very similar to what we have a chain rule in calculus. We can see what are the problems that can be solved by deep learning, like classification, detecting a spam, product recommendation. We can see YouTube detecting a spam, right? Like we already using it in our Gmail, medical diagnosis, and customer segmentation and lifetime value prediction. So we can calculate lifetime value predictions of many customers also, and we can decide which customer to focus and which customer to let it go. And here, how we can do machine learning is like today, many of the libraries are available for us to do machine learning. We really don't need to write our machine learning algorithm. Just any developer can start and achieve something on machine learning also. And for that, they need to use the API. If some of the APIs are not available, then we don't have a choice, and then we have to do using the core concepts by writing a core algorithm, which we can write using the ML frameworks or the AutoML given in the left and the center. But if we have a common task, then it's better to use the API than to use the than to write the whole ML, because ML thing is time consuming, and also it has a lot of computation cost also. For example, if we have a lot of data, for example, object detection, it's better to use a API than to train a model, because training model would require us a lot of data and plus the computing cost also. So based on the uses, we can choose which flavor we want to use. If we have really something research and API not available, we can go for ML framework. Some of the things can be done by AutoML also, where we just need to bring the data. In machine learning API, for example, object detection, natural language processing, machine translation, we can directly use API, and particularly APIs are available on Google Cloud and Amazon Cloud called AWS. And here we can see what is the performance of this. We can see that ML framework, ease of use is very less, because it requires us the learning technical capability to learn to be enabled. Whereas in machine learning APIs, any developer can simply start working. It's very flexible to use, almost ready, and you can start working without any knowledge of machine learning. And we are having lots of machine learning APIs available. We can explore them as per our requirement. But if the thing is that it is not available, we can always go for writing our own custom machine learning. And we will see some of the machine learning API. So here are Vision API. So we are having object recognition API available in the cloud, as well as facial, sentiment, and logos detection API, extract text. For text extraction also, we are having APIs available, detect inappropriate content. So we are having this API, which we can directly use from Google or Amazon Cloud. The terms are slightly different in Google Cloud and in Amazon Cloud, but it's available, and it's recommended to use this API than to writing the scratch, than writing the ML from the scratch. But if the task is very new in nature, we can always write the machine learning algorithms. Here are some of the things for NLP: entity recognition, sentiment analysis, multi-language support, and syntax analysis. In a speech, we are having a speech recognition, word hints, noise, robustness, real-time results, and all of these are available in over 80 languages, and these are being used widely in the chatbot programs as well as automated calling features. We can give a text, and that can be used using a speech API. We are also having translation API. I think that all of us have already used it. So translation, so we can automatically translate text, and we can detect language also. We are having continuous update behind the scene translation API, learning from the logs analysis. So this is also can be done, and these are available in premium editions also. So it allows for like more and more like pay as we go. So these are things, and we are also having video intelligence API for level detection, enable video from scratch, insight videos from the scratch. That is video summary. It can give us the video summary also, and a lot more. So we can directly, instead of writing the videos algorithm, which for sure would consume a lot of data and a lot of computation, directly we can use video intelligence API. And once we are having the API, right, we can integrate with our messengers like Amazon Alexa, Telegram, WhatsApp, Facebook, Slack, Twitter, etc. So we can integrate all of this with. So these are the latest trends having how machine learning is being used in industry. And then we can see it's not who has the best algorithm who wins, it's who the most data. So this is just to remind that API and everything is okay, but behind the scene, which is translating, which is doing video analysis, it's all the data. And now we will have a look in the trends in MLP. So the latest trend in MLP is the transfer learning, basically, because we are having the models which have already consumed all of the internet data, and for any individual human and or for a small organization, it would be very difficult to write a model which can consume all internet data and to compute on that and to build a machine learning model of that. So that is very difficult. So in general, transfer learning is the top trending thing when it comes to NLP. And for this transfer learning, right, like the latest things which we have are called GPT-2, GPT-3, that is from the OpenAI platform. And we are also having the BERT, which is from Google. So we can explore these things to achieve the desired result. So the transfer learning is one of the trending things in this NLP. And one of the things for which NLP is being used is cyberbullying. So people are doing a lot nowadays. So cyberbullying and NLP detects all of these cyberbullying things very well. Other thing is like social media monitoring, and the use of multilingual NLP is increasing day by day. So like for example, like translation API. So we are having already in general tokens available or the word vectors available in many different languages, so that we can build classification algorithm or whatever algorithm we are wishing on top of these different languages. So now with advancement in this machine learning and NLP, we can build and use pre-trained model which are already available in different languages. It is not limited to English only. And the next thing is tagging customer support for tickets. So automatically whole thing, like we can tag customer and we can create support tickets using NLP, which includes chatbot also. For example, right, like when suppose we are having internet connection not working very fine, then automatically the server of the IP provider can detect the failure, can create the ticket, and automatically get resolved also. So NLP can be used here also. And with this, right, like the rise of low code tools are on high. We can see Monkey Learn, a SaaS company, aims to democratize machine learning and natural language processing by making them accessible to non-technical people. So AI is basically coming to a level where like technical knowledge might not be required, and it will be accessible to very non-technical people or people from other domains also. The company has created a model that allows you to create, train, and integrate emotional analysis and text classification model using a point-click interface. So any non-trained people also can create their model going forward. That's what it points to. And this is what we can see, right? Like the chatbots and the spam filters. And we will see now what are the latest trend in computer vision. So these are the things: computer vision for safety and security. Here we can see that gloves off in picture 5. Hard hat is already there, safety vest is already there. And so this is how automatically computer vision can help in security lapses and ensuring the safety is paramount. Almost similar example here, how facial recognition can work. For example, which employee is present, which employee is not present. And this kind of APIs are working in many countries, like in Dubai, for a smart channel, I think, or a smart pass, something like that, at Dubai airport. There, we don't need to have a passport getting stamped. So just by seeing the video, it does the rest of the things in the background. And the latest one of them is like edge computing. So edge computing decreases the use of internet while using the video. Attached to a physical machine, edge computing allows quick data processing and data analysis right where it is collected. So naturally in industry that often witness a network failure, this particular aspect of real-time computer vision can help tremendously, require neither a data center nor a cloud. So even in terms of like without having a data center, cloud, or even internet, edge computing would help taking decisions in real time. And here we can see example how it's happening. So we have seen how the robot sweeper picked the ripe fruits, and it picked correctly. And here is one of the examples of the healthcare we can
We're
see.
all touched by cancer in one way or another. Every cancer is different. Tumors can have hundreds and thousands of cell mutations. How do we find that one change that we can target and treat that cancer?
There's millions of scientific articles covering specific mutations and combinations with drugs.
We can't possibly keep up with all that literature.
The clinical knowledge base is an innovative technology where all those variants, mutations that exist in cancer are being curated as they're discovered by researchers around the world.
That's where our collaboration comes in with Microsoft AI to help us triage the literature. Machine-assisted human curation can assist going through all of those publications and saying, this is one, so that the team can use their scientific expertise to interpret them.
It's a life or death situation. It's also a question of how you accelerate certain discoveries and bring them into clinical practice. We have a stage 4 esophageal cancer patient, they're 60 years old.
We can more accurately predict patient responses to a combination of targeted therapies, immunotherapies, and even drug resistance. It is that funnel to be able to get to the right mutation with the right treatments associated.
With Microsoft AI, oncologists will be able to improve patient outcomes.
Every morning I wake up to fight cancer. Through the collaboration with the Jackson Laboratory and Microsoft AI, we can know that we haven't missed anything. And it's just been wonderful. We're all touched by cancer.
And that's what we see. Artificial intelligence is everything today, at least. And it has a lot to contribute from healthcare to agriculture to jobs to whatever we can say. AI has touched, and whatever it has not touched, it is going to touch almost all aspects of the life. And for somebody looking for job and having the professional growth, here are the stats. We can see like 21 million developer and less than 1 million data scientists are there, and just thousands of deep learning researchers are there. So it's very much needed that people should learn AI and move into it. And artificial intelligence is contributing to society. So we should also contribute whatever we can. And that's all from my side. Thank you all.
So any clarifications from participants?
Lavanya ma'am.
Sir, yes, sir.
Actually, a very interesting one. So many applications in the machine learning we can identify. The question is, so he has used the term linear regression. I want some clear explanation about the regression.
Okay.
Sir?
Okay, yeah, sir. So basically, regression is the technique to identify patterns from the data. So basically, regression is nothing but given like you have say thousands of the data, and what you are doing, it helps us to find a given line. Actually, when it is linear in nature, like every day you are waking up at the same time, like say 8 o'clock or 6 o'clock, you are linear in the nature. So given the data, like what time you are waking up in the past, we will be able to find what time you're going to wake up tomorrow or the day after tomorrow. It's called the linear regression. And there are scientific ways to calculate it basically, and even we can calculate it using normal algorithms, even by hand mathematically using statistics. using many of the tools for classical machine learning today, and the deep learning library like TensorFlow and PyTorch also. So yes, sir.
Okay, sir. Okay, sir.
So is it okay, or you need
Yeah.
more?
From your example, I can understand the regression, sir.
Yeah, in simple, we can understand that, like, given past, we are trying to predict the future using linear regression. Yeah.
Okay, sir. Thank you, sir.
Welcome.
Any more questions?
And even if anyone is having questions and it comes to their mind offline, right? Like they can, I have given my details in the group. They can reach me on my LinkedIn or at my personal email also. Thank you.
Naveen, I have a question. Like, what type of skill set is expected from students who want to pursue as data scientist or data analyst?
They should be very good in mathematics, basically. Should be able to know the this kind of equations. For example, how this linear regression has been calculated by hand, and how they can calculate this non-linear regression by hand. That is one of the mathematical aspects. Plus, when there is non-linear regression kind of things, which we don't see, they should be able to understand the gradients, the slope, this kind of things. They should have a very good solid base, because what happens in general, we are having the frameworks, we constantly do mistakes and constantly get bad results. Program doesn't throw the error. So the logical ability to visualize what's going behind the code, because we are having just 2 lines for linear regression in code, but we don't have to get the output alone. We need to make sure the output is correct theoretically based on real sciences. So that kind of basic understanding of mathematics, statistics, calculus, linear algebra is required. Then very solid coding in Python is also required. And then comes the ML frameworks. So if they are having good basics, for example, programming, in say Python, and good mathematics, they can learn it very fast. But what is happening nowadays? Students are coming learning data science having no knowledge of linear regression. So that is enlarging their time to learn data science.
So your advice will be like they have to be little strong in maths and mathematical models.
Yes, because ultimately, for example, in my case, we display advertisement in entire US, and for say, I gave example like a refrigerator or fan or whatever, AC repairing, whatever, and I can display ad to each and every user in US, but there is a cost associated to this advertisement. Now the user should buy, then only I will be getting profit, and I cannot, for a refrigerator say 20,000, I cannot display at 20,000 people, because even if I am spending 1 rupee for one ad, which is actually more, say 10 rupee for per ad, then I will not be in a profit with selling refrigerator. So these huge complication calculations are there behind all of these machine learning models. So they should have a strong mathematics, no doubt about it.
Yeah, like is there any specific tools for interpretation of the results, Naveen?
Not much, ma'am, but for data analysis, people are using Tableau and all.
So that's you can say we can use it for visualization, right?
Visualization, but not for analysis. Analysis, they should have top SQL skills, and they should have ability to code back those data in Tableau or in Python like Matplotlib. And what I do in general is I create my own pivot tables to do that, which I can, yeah.
There's another question from the audience. Can you please elaborate on NLP API and BERT?
Yeah, sure. So NLP APIs are basically APIs which are already being used in production nowadays. For example, when you do Google Translate, you are using this translation API of the Google. But if you want to use it in your own product, in your project, for example, you're passing Tamil and you want to get English, or you're passing English and you want to get back Tamil, then you need to subscribe to Google or Amazon API, the translation API, and that will be subscription per month, or the number of text you're fetching. That will be on the subscription basis. And these APIs are available from Google and Amazon also. So this is what the translation API is. And many more APIs are there which anybody can explore. And considering BERT, so BERT is the latest model which has used auto encoder, encoder decoder architecture in the background, but it is far powerful than that. And so basically this model has Google has used all of the internet data for, it does multilingual things, basically using all of the internet data. So we can use it for many purposes. Technically also we can use BERT. BERT is a architecture and a style of doing neural network model. It's a research by Google. On the other hand, we are having pre-trained BERT model. For example, if I want to translate, let's say if I want to generate text, or if given a paragraph, I want to summarize my text, I can use BERT model, pre-trained model, which is available free of cost on internet.
Okay.
Yeah. So does
but that BERT which is available on internet, like it is it is not actually the latest version of it. Since the Google is using it, like they have their own the add-ons and plugins. It's not available actually fully.
But ma'am, whatever is available, that is good enough for general purpose tasks. And and the other thing is that we are having huge models also available. For example, one of the model now which is par with BERT is GPT-3, and GPT-3 is also publicly not available. But for GPT-3, we are having GPT-J, which is a mimic of GPT-3. So GPT-J is available, but it requires 48 GB of CPU. So, so most of the tasks can be done, and if not done, we can write back to Google or to OpenAI platform based on our need. They provide it, and they provide it very fast if we are working in healthcare sector and all for life-saving AI purpose. They provide a free access to all of this BERT and GPT-3 kind of things. So if somebody is having those projects, it can be accessed by requesting them.
Okay. So again, on behalf of students, like is it possible that a student can directly with no experience can be apply for data analyst job, or is there any prerequisite for applying for data analyst job?
Basically, ma'am, there is no degree kind of requirement for these jobs, or you can say that for any IT job, we can assume that degree requirement is almost over. But at the same time, they look for some of the credentials also, like our works, which can be published on GitHub. And for example, how many answers we have given on a Stack Overflow. We all use a Stack Overflow, but if we answer a lot, say 1,000 or millions of answers, then people doesn't need to search the job will come to them. So there is no degree requirement, but knowledge requirement is paramount. And the other thing is that with a very basic degree and having knowledge of all of the things like basic HTML, basic Java, basic Python won't make sense nowadays. Like when I got passed from our university, I won't say that I was intelligent, but I would say the time was good that my being average worked. But for now, being average won't work. The reason is that we consider this thing, ma'am, that consider any banking company like SBI. So SBI was initially in phase of making applications like forms, this validation. So those works were very easy. How to build a form in HTML, click submit button, and then it will load all of these pages. So those phases are over almost, or are in maintenance phase basically. So all applications you can say has almost been built. The only thing is that how can SBI attract more customers behind the scene, which can be done using data analytics. So, this is the new age where people are required to know a bit complex knowledge of all of these tools. And with basic syllabus, I don't think they are going to get job easily. It will hurt them.
Any more questions from participants?
Ma'am, there is a question in the chat box, like suggest us any online certification course for data analytics.
Basically, there is one on Coursera, deep learning by Andrew Ng, which you can do. But again, even if you do that course, you are expected to go with solid calculus understanding, solid math understanding, like if you're having math background, right? Like, you know, how can you solve two variable equation having X and Y. So consider how you're going to solve 1,000 variable equations. So linear algebra, calculus, basic math, slope gradient calculations, these basics, if you brush up very fast, then you can join any course is advisable. Basically maths, because it's going to be very tough when you are learning it and in production. And one of the most important skill you should always focus is writing excellent SQL. Yeah.
Okay.
Basically, any online course would help a lot of. So like, as you could try many courses, and in many courses you see that which course you are able to grasp, and you should know, keep learning that. And it takes time actually. It takes at least a year or two if you are having good science background, because science, maths plus code, both are required. And coding also, I would say that average skills are required here. Hello, ma'am.
Can you suggest some interesting research problems for the beginners in this domain?
Yeah.
Challenging and interesting research problems in this domain.
Yeah, many one, like they should try to translate language from English to Tamil, Tamil to English. They should try using the pre-trained models available on internet. Yeah, they should try something like given an article from internet, any article from internet, they should be able to find names, organizations, places. So in terms of NLP, they should try to understand, find object recognition. They should build an object recognition model, and they should take a photograph from own mobile camera, and they should give that to model and check if that model is predicting correct or not. So these are the applications they should work actually, and they should try to build it very large also. If they start building in the first year, by third year they will be very good. They should keep working on the same problem.
So people are working with Python with the packages. Is there any other tool which will help them to do the analytics?
a Python alone with SQL helps a lot, ma'am. But they should be excellent in Python, know the Python tricks. They should write the minimum code. For example, in terms of data science model, no for loop is allowed.
Yes, yes.
No for loop is allowed. So they should understand the basic concept like vectorization. So how vectorization helps. Yeah, so these are, I mean, I have seen people writing Python, but not writing Python good. So that won't help. So they should write, they should basically start liking the Python. They should dig it more and more. That's the only way. If they are doing for the namesake, they are going to fail basically. If they're following a syllabus, they are going to fail. If they're going to like it, that okay, I will fail, but I will try to do and I will do better, then only they are going to succeed in this line.
With passion, right?
Yeah, the only thing is passion. This should not be no, like I have to do that. I mean, following syllabus doesn't matter here. The following the problem. So they should be able to, I mean, if I give them to just translate it, right, to English to Tamil, so they should not go Google it and translate it and come back to you that, ma'am, I have solved my task. They should go, they should learn that how tokenization is happening, what is a token, and they should also know that where the translation is failing, and they should understand, can I make this translation better? And then they should dig the network architecture. So the one problem alone, if they work passionately, will help.
Thank you very much for your elaborate answers.
A pleasure.
And wonderful presentation and useful for the people.
Yes. Yeah. And one more thing for researchers, like we have seen that like APIs are available. So if any of us are making our API, some of the research like translation or object recognition, we can launch it our own server, and even we can give subscriptions to other. So in two way, right? Like the subscription can help users to get their task done without creating a model, and for the researcher they can earn money as well.
Okay. Thank you.
Any more questions from audience participants? Okay, then thank you, Naveen. Thank you very much for your interesting session actually, and elaborate question and answer session also. A couple of minutes for a formal vote of thanks.
Yeah. Thanks a lot, man. Pleasure.
Good evening to one and all present here. It gives me immense pleasure in delivering vote of thanks to everyone who has helped in this, making this second day International Congress on Industry Perspective of Data Analytics a grand success. I'd like to thank our resource person, Mr. Naveen Kumar, Senior Software Engineer, Media.NET Hyderabad, for your wonderful knowledge sharing and interactive and informative session. Thank you, sir. I would like to thank all the participants who are all present today. Let us meet tomorrow at 3 p.m. with another knowledge-based session on integrating robotics process automation with data analytics by Mr. B. Saravanan, former Senior Director, CTS. Thank you all.
Thanks a lot. Bye.
Thank
Bye.
you. Thank you.
Thank you, sir.
Thank you for spending your valuable time with us, Naveen, as well as Professor Kadivalam Kumar sir and others.
Thank you, ma'am.
Yeah.
Thank you everyone for your patient participation.
Yeah.
Okay, let us meet tomorrow.
Yes,
Sure,
sir. We'll
sir.
meet tomorrow, sir. Thank you,
See
sir.
you tomorrow,
Thank you.
sir.
Thank you.
See you each one of you tomorrow by 3 p.m. Okay. Thank you all.
Thank you, ma'am.
Thank you, Pandian, for joining us.
Yes, ma'am. Thank you, ma'am. Thank you so much.